Welcome to this series on using .NET Aspire to create and deploy microservices. I'm Johnny Devcraft, your host for this adventure, and we're about to embark on a journey through coding that will help to demonstrate the capabilities of .NET Aspire and how you can take advantage of those capabilities to build cloud-native applications that are ready to scale on demand. I want to discuss the difference between a traditional monolith and a microservices architecture. There's a ton of hype around microservices in the industry today, and sometimes it can feel like a monolith bad, microservices good situation. Still, I believe oversimplifications like that can be dangerous for project designers, and architects need to take the time to examine the real needs of the project before jumping on the microservices bandwagon. Microservices are great for cloud-native projects where the need to scale components individually exists, but they have a ton of drawbacks that you need to be aware of. First off, they're very complex, require much planning into how to version your messages, and debugging can also be very painful. Telemetry in a microservices environment is very important, and you'll want to ensure good visibility into your application. If your needs can be accomplished in a monolith, you should consider it seriously. KISS or KISS definitely applies. Now, if you're set on building a microservices application, here are some things you're going to want to make sure you avoid. First, don't make the mistake of believing that microservices are all about size. I've seen too many projects where the company started breaking apart their services into smaller APIs that would communicate with each other through HTTP requests. Each call to another service became blocked, and the contract was very tightly coupled between the services. Second, databases should not be shared between microservices. Once again, this creates a point of tight coupling where changing the data model could affect other services. And third, and honestly, I could have just started here, you want to avoid doing anything that creates tight coupling between the services. Small services that are dependent upon each other directly are still a monolith. You've only managed to make your monolith a distributed monolith, and in the end, there'll be no benefits gained and a ton of extra work to manage this new system. In this course, we'll build a microservices-backed application. To get this right, we need to think long and hard about several different things. First, we must consider how to version our contracts to maintain backwards compatibility as our application grows and evolves. Next, it's important to focus on enhancing our system's resilience. To achieve this, we will explore concepts such as the outbox pattern and dead letter queues, ensuring that our messages remain secure and they aren't lost in transit. Third, we need to consider each service's data storage needs independently. Even though we're designing all the services, they should each have independent data stores. They should expose data as needed through contracts, and it's better to do this through interfaces that allow for minimal requests from the requesting components. Fourth, we want a well-designed gateway for our services that controls data flow from the front-end applications to our back-end. For this purpose, we'll use SignalR and RESTful web services. What are we going to build? I give you Pizza Maker IO, the future of pizza delivery. Our revolutionary system takes all the waiting out of pizza ordering. We start by using a state-of-the-art robot to fetch and manage ingredients. Then we cook the pizza using the Super Pizza Cooker 4000, which can cook a fully assembled pizza in just 90 seconds. Next, our robots load the pizzas onto a transporter pad, where we'll deintegrate the matter and beam it into your home for instant tasty dinners. This system is completely automated and, of course, made up, but it will help us design something really cool. In the next video, we're going to dive into the components and design of the system. So tune in.